Welcome back to part 21 of my DIY autonomous mobile robot building series. Today in part 21, using Fusion 360, we will create and position the remaining aluminium spacer tubes between structural components and add bolts while making sure the bolts don't interfere with the robot body. If you're just joining us, be sure to check out parts 1 through 20. The links are in the description and the full playlist is at the end of this video. Okay, so moving on from part 20, I think we should add a few more structural components to the chassis. Here, outer wall 1 is hidden and outer wall 2 is the one currently visible and facing the viewer. Unhide the sketch for outer wall 2, right-click and edit the sketch. Let's hide outer wall 2 momentarily. Press P to project the profile of the upper component of battery pack rear hook 3, project the rear end of the nylon nut here, project the top of this nut just in case, and project the header block here of the Arduino Uno. Hit OK. Unhide outer wall 2. Here the footage has jumped ahead a little, where we have this unconstrained 11mm diameter construction circle. We also have a construction line extending from the bottom right corner of the projected rectangular slot to a projected point on the nylon nut. And also at right angles to that line, a construction line that extends to the top right corner of the projected header block of the Arduino Uno. Select the coincident tool, select the center of the 11mm diameter construction circle, and then select the right angle construction line here, and the circle initially aligns with that construction line. Then with the coincident tool still selected, select the construction circle, and then select the top right corner of the projected header block of the Arduino Uno, so that the circle also becomes coincident with the top right corner of the projected header block. The 11mm diameter circle is a little large and doesn't quite fit within the projected boundaries, so let's change the diameter to 9mm instead. But on further inspection, we can see that the circle still doesn't quite fit, so let's make that 8mm. Now select the circle tool and create a 3mm diameter circle at the center of the 8mm diameter construction circle. We need to remember that this sketch has actually been carried out on outer wall 2. However, we might as well sketch the profile around this hole for the upper component of battery pack rear hook 3 while we're at it. Select the circle tool again and sketch a 7mm diameter solid circle, which should provide enough material around the 3mm diameter hole. The footage has jumped ahead a bit. Here we have finished the sketch and we just need to activate battery pack rear hook 3, right click and isolate. Go down and unhide outer wall 2 and unhide the sketch. Here the footage has jumped ahead again with the 3mm and 7mm diameter circles projected onto the upper component of battery pack rear hook 3. Now swivel the design a bit, select the extrusion tool and select the section to be extruded and extrude by 3.7mm. We'll just unhide the sketch again and this time use the extrude tool to extrude by 3.7mm to form a 3mm diameter hole. Go up to the top of the browser and activate the main design. Then go down and hide the sketches, zoom out and turn the design around, and it looks as though I have already extruded a corresponding hole in outer wall 2 off camera. So go back up to the main design in the browser, right-click and select Show All Components. Slide back down and hide the lower body, and also the left head and the right head. So we're ready to design spacer tubes to fit between the upper component of battery pack rear hook 3 and outer wall 2. Before we carry on, let's hide the wheels. Rotate the design to the other side. Now go down to battery pack rear hook 1 in the browser, activate it, right-click and isolate it. Select the outer face and create a new sketch. Unhide battery pack rear hook 3, which shows no change because battery pack rear hook 1 is activated and battery pack rear hook 1 is on the opposite side. Anyway, the footage has jumped ahead with the profile of battery pack rear hook 3 projected onto battery pack rear hook 1 with the front circular profile extruded. Let's use the extrude tool to form the front 3mm diameter hole by extruding by 3.7mm. Hit OK and hide the sketch. Here the footage shows the main design activated. Okay, let's activate outer wall 1, select the outer face and create a new sketch. Press P for project, select battery pack rear hook 1 to project its profile onto the sketch of outer wall 1 and hit OK. Finish the sketch. Select Extrude and extrude the projected 3mm diameter circle by -3.1mm to form a corresponding hole in outer wall 1. Activate the main design. We want to create more aluminium spacer tubes for connecting the holes that are formed between outer walls 1 and 2 and battery pack rear hooks 1 and 3. So we'll need to use the measuring tool by selecting Measure from Inspect, selecting the inner face of outer wall 2, and then turn the design around to select the outer face of battery pack rear hook 3, and we get a distance of 12.35mm. Hit OK. I also measured the distance between battery pack rear hook 1 and outer wall 1, and it came out to exactly 12.35mm, which confirms there is no error in the chassis design in that respect. Here the footage has jumped ahead a bit. We'll need new washers at our newly formed holes, so let's select this M3 washer, select the Move Copy tool, check Create Copy from the Move Copy palette, and move the copy of the M3 washer away from the original M3 washer. Hit OK, and then from Assemble, select Joint. Select the central snap point of the surface of the M3 washer copy, then select the central snap point of the hole at the outer face of outer wall 1, and the M3 washer glides into position. Hit OK, then do the same for the corresponding hole of outer wall 2. Before we carry on, let's select these M3 washers in the browser and move them to the M3 washer group. Open up the Joints folder, which will be in the Relationships folder in the latest version of Fusion 360, unlike in the footage which was taken before that update. Rename each new joint to M3 washer. Let's hit the Home icon at the top right corner. From Create, select New Component and label it 12.35mm tube, inner 3mm, outer 4mm. Right-click on this new component in the browser, select Isolate, and everything disappears because we haven't created the tube yet. Create a new sketch and select any plane, and just like we did in the previous video in part 20, use the Circle tool to sketch a 3mm diameter inner circle at the origin and a 4mm diameter outer circle. Finish the sketch and extrude the area defined between the 3mm and 4mm diameter circles by 12.35mm. Now go up to the top of the browser and activate the main design. Let's just select the outer circumferential surface of the tube and apply a fillet of 0.1mm. Let's also press A for appearance and apply an aluminium colored pigment. Move the tube to one side and then go down to the bottom of the browser, right click on the 12.35mm tube and unisolate it. Zoom in to the end of the tube and use the Joint tool to attach it between outer wall 2 and battery pack rear hook 3 at their respective holes, in the same way that other spacer tubes were mounted in part 20. And there we have the 12.35mm tube in place. Now all we need to do is use the Move Copy tool to make a copy of the 12.35mm tube by selecting Create Copy on the palette, sliding the copy away to the other side, and then use the Joint tool to attach the tube in between outer wall 1 and battery pack rear hook 1. I also initially created a central tube to fit between battery pack rear hooks 1 and 3 at a position aligned with the pair of 12.35mm tubes, but I ended up removing the central tube later on in the design process, so we'll move on. Now we can just use the Move Copy tool to create a copy of the 12.35mm tube, slide the copy away, and use the Joint tool to attach this tube between the aligned holes at the rear of outer wall 1 and inner wall 1. Then create another copy of that tube, slide it out to the other side, and attach this 12.35mm tube between the aligned holes at inner wall 2 and the rear of outer wall 2. Select the Measure tool, measure the distance between the inner faces of inner wall 2 and inner wall 1, and we get a distance of 26.4mm. Create a new component and label it in the same way as the other tubes, but with a length of 26.4mm. Isolate this tube component, create a new sketch, and sketch a 3mm inner circle and a 4mm outer circle. Finish the sketch and extrude by 26.4mm. Add a 0.1mm fillet as with the other tubes and color it with an aluminium pigment as well. Next, move this tube out of the way, scroll down and unisolate this tube and activate the main design. Move the tube to the rear side of the robot and use the Joints tool to attach the tube in between the rear holes of inner wall 1 and inner wall 2. Lastly, we can make a copy of this 12.35mm tube at the front, Move it back and attach it between the corresponding holes. And there we have all of the aluminium spacer tubes connected. As always, make sure you label each joint. I labeled them tube connection. Now it's time to insert some bolts. From Insert, select Insert McMaster Car Component, select Screws and Bolts, select Metric, select M3 and scroll down for the length. We actually want an 80mm length, but there's only a 70mm one available before it jumps to 145mm, which would be way too long. So select 70mm, scroll down and to the right, and click on the link here. Select the step file and download. This automatically inserts the M3 bolt into the design. Move it away from the rest of the design. Scroll down in the browser to the new component and rename it M3 80mm socket head screw. Now we need to extend the length of this M3 bolt from 70mm to 80mm. Let's open up the bodies folder and also right click and isolate this component. Get the bolt into position. From Modify, select Split Body and select Capture Position. Here's the split body palette. Select the bolt as the body to split. Select the undersurface of the head as the splitting tool and hit OK. First, let's use the Measure tool to check the shank length. It measures 70mm as specified. As we can see from the Bodies folder in the browser, the splitting operation has divided the M3 bolt into two separate bodies. Body 2 is the shank and body 1 is the head. Select the head, select the Move Copy tool, move the head away from the shank by 10mm and hit OK. Select the Extrude tool and then select the top surface of the separated shank and extrude by 10mm. This automatically switched to a join operation so that by hitting OK, the shank and the head become a single body again, an 80mm M3 bolt. Now we can press A for appearance and apply a black pigment. Now the M3 bolt is ready for the chassis. Right click on the M3 bolt in the browser and unisolate it. Swivel the design around and let's select the Joint tool from Assembly. Select the central snap point on a plane that lies on the undersurface of the head and then select the central snap point on a plane that lies on the surface of this washer. And there the M3 bolt glides into place. Turn the design around and there the threaded end of the M3 bolt extends through outer wall 2 and the washer. Before we carry on, we need to check that the end of the M3 bolt doesn't interfere with the body. So let's unhide the lower body. I also unhid the wheels, but that actually wasn't necessary. From Measure, select Section Analysis and initially select the YZ plane for our sectional plane. The cross-sectional view is on the wrong side, so select Flip in the Section Analysis palette. So there we have a vertical cross-sectional plane extending in the lateral direction or left to right direction through the origin. Grab the arrow and pull the sectional plane forward to where the M3 bolt is. Zoom up to the end of the M3 bolt and we can see that the bolt comes very close to interfering with the body, although it could do with having a few extra washers at the head to move the end of the bolt further away. Hit OK, hide the lower body, select the M3 bolt in the browser, select the Move Copy tool, check Create Copy and move the copy of the M3 bolt away from the original. Let's quickly assemble this new M3 bolt through the upper front aluminium spacer tube via the holes in outer walls 1 and 2. Here the footage has jumped ahead showing the section analysis of a plane passing through the center of this new upper M3 bolt. Let's go to the browser and unhide the lower body. Zoom up to the end of the upper M3 bolt and we can see that the end is a little too close to the lower body, so we'll definitely need to add washers at the head to move the bolt to the right away from the body. Hide the lower body again and hide the section analysis. Open up the Joints folder, which unlike in the footage will be inside the Relationships folder in the latest updated version of Fusion 360. Then scroll down to the last two rigid joints, right click and remove them. I selected Delete in the footage, but selecting Remove is actually safer. Upon removing those two joints, we have the two M3 bolts unmounted and positioned away from the rest of the design. Select the upper M3 washer, select the Move Copy tool and create a copy by selecting Component, checking Create Copy copy on the pallet and moving the copy of the M3 washer outwards by 0.5 millimeters, the thickness of the M3 washer. Hit OK. Here the footage has jumped ahead so that there are now 2 additional washers. Let's just quickly mount the M3 bolt again. Unhide the section analysis and scroll down to the lower body in the browser and unhide it again. Zoom up to the end of the upper M3 bolt and we can see that there is plenty of clearance between the end of the bolt and the lower body. We can also confirm that the 3 washers do not move the head of the M3 bolt too close to the lower body either. Here the footage has jumped ahead where you can see that I have done the same for the lower M3 bolt as well. Now hide the section analysis and hide the lower body. Before we carry on, we should label those new joints. I labeled them M3 bolt to walls. I also tried to do the same for the uppermost holes in outer walls 1 and 2 to allow another M3 bolt to pass through outer walls 1 and 2 and inner walls 1 and 2 via each connecting spacer tube by adding 2 M3 washers. However, upon confirming using section analysis with the lower body unhidden, both ends of the M3 bolt penetrated through the lower body. In fact, there isn't even room for the head of the M3 bolt, even with no washers. So hide the section analysis and scroll down to the joint for the uppermost M3 bolt and remove it. I used delete, but remove is the safer option as I mentioned before. And there the M3 bolt is at an arbitrary position. Hide the lower body. Since we can't use this M3 bolt at the uppermost holes in outer walls 1 and 2, etc., let's hide the left and right wheels. Quickly move the 2 additional M3 washers onto the M3 washer that is at the central hole, which aligns with the hole in the battery catch component, and mount this M3 bolt there. I'll just label that new joint, just like the others, M3 bolt to walls. And by the way, there's the other end of the bolt. I will put the M3 nuts on the ends of the M3 bolts later. So here we have the problem of how to mount the front of each battery pack rear hooks 1 and 3 to outer walls 1 and 2 via the uppermost holes. Click here for part 22 to see how I dealt with this problem. If the link isn't showing, part 22 isn't quite ready, but should be soon. Check the description for my upload schedule. Thank you for watching.